linear equations in slope-intercept form using slope and y-intercept. Overall summary of what we're doing. When the y-intercept, our b value, of a linear function is positive, the line moves up. When it is negative, the line moves down. So our main focus today is what happens when we change our b value of the equation y equals mx plus b. Things to remember is that our parent function is y equals x. Today we'll be dealing with the function notation a little bit more. So the parent function in function notation is f of x equals x. Other linear functions can be created by changing the slope and the main portion, the y-intercept of the parent function. That'll be the main portion for today, that is. In example number 1, we've already graphed f of x equals x. It goes through the origin because we are not adding anything, so the y-intercept is 0, 0. And our slope is 1. The number in front of x, since we don't see it, is understood as 1. So we can go up 1 and over 1 to our next location. When we are only changing our b value, when we are only changing b, we are only going to take this line and move it up or down the y-axis. The slope's not changing, so I know my slope will still be going up 1 and over 1, but I now know that my start has to be at -4. The location, 0, -4. So I know my location has to be here. Now, following the rule of up 1 over 1, we can start creating our line. I'm going to try my best to get this straight as possible. But it snaps away like that. So I have to do it freehand. With a slope of up 1 over 1, or a slope of 1, it's pretty easy to do. It goes through the next intersection of the points. So it's easy enough to line up. So in this case, this would be our g of x function following the rule x minus 4. So that we know what it is on the graph, we can label it. G of x. On our example 2, we have the same setup where it wants us to graph our f of x first, which I already did. And now it wants us to go up to a y-intercept value of 0, 3. So yet again, we still have the same slope. Trying my best to keep a straight line. So on this graph, we took our line and we shifted it up a total of 3 units. We want to make sure that we label this as well. As g of x. Now, make sure I'm phrasing this right. When we are looking, oh, wrong thing. There we go. When we're looking to identify the translation, as I stated, starting from our f of x, we want to focus on our we want to focus on our origin And we want to see how it shifts when we are only changing the y-intercept value, our b. In this case, when we have g of x equals x minus 4 from the parent function, we are shifting down 4. And our second example, going from our parent function to the g of x, we are shifting up 3. The next part is a little tricky since this is the first time we're actually showing it. It's asking you to express g of x in terms of f of x. Now, if we compared every value of the same x, what's going on is that our output, our y value, is subtracted by 4. So how we explain this in terms of f of x is that our g of x is our f of x but as I stated, it is shifted down 4. I'll keep this to where y'all can see it. But our g of x is equal to our f of x function minus 4 for every value that we get. So for our origin, when our x is 0, our y was 0. In this case, the value was shifted down for that same x value. And that's how it goes throughout the line. At any point, whenever I find my output of f of x, the output of g of x with the same x value is shifted down 4. It is subtracted 4 from f of x. The other one is set up the same way, where we just focus on the expression itself. We are only changing our output. So this is g of x equals f of x, making sure we have lowercase to match up. And this is adding 3 to every one of our y values. So looking back at our graph from our origin, we have 0, 0. Our g of x function with the same x value is 3. And it repeats throughout the entire line, whatever value we have. So when our x value is 2, our f of x is 2. Whereas our g of x is shifted up 3 to our value 5. So we're just taking our function of x and we're adding 3 to it to express our g of x. Example 3 gives us an opportunity to work backwards. It gives us an equation. It already shows that our line does not change its slope. It's still up 1 and over 1. So we don't have to worry about our x value changing. Our slope value changing. So we still have x. And the last piece, starting from our origin, because our parent function goes through the origin, we had to go up a total of 3 units. So to express that in the equation, we show a plus 3 to finish off our expression. So in comparison to the parent function f of x, which we know goes through the origin, g of x would be the x value adding 3. To express this in terms of f of x, whenever we get the output of our f of x, we are simply adding 3. Now to take a verbal description and change it into our equation, it's asking us to write an equation of the function described by given transformation of the graph f of x equals x. So it wants the transformation from the parent function. For this, it's saying that it is translated, it is shifted 2 units up. So this is showing that up is positive, and it wants to be up 2 units. So now if I write that as the equation, if I can get it into the right spot, we're saying that g of x is equal to our x value plus 2. So this doesn't change much from what we had up here, but instead of us describing it, we are given the verbal description, and we're creating an equation out of it. If I were to write this on the graph, that means that I would be at a value of 2 for my slope-intercept value. I'm sorry, our y-intercept value. And then we would create our line from there. To express it in terms of f of x, yet again, we are just taking our function of x and we are adding our given value to it. We are adding 2 to our output. Now, sometimes you're going to be given equations that do not start from the origin. In this case, our f of x is not the parent function. It is going to start at the y-intercept value of -5. So the origin would be at 0, -5. The y-intercept would be at 0, -5. When we shift up from this, we are going to be adding 10 to our -5. So we still have the x to begin. -5 plus the 10, since we're shifting up, gives us a +5. So then we have the equation. G of x is going to equal x plus 5. Now this is only 5 units above the parent function, but it is 10 units above our given f function, which was x minus 5. Now this changes how we express g of x in terms of f of x. When we look at f of x, we are only shifting it up 10 units. So this will still show that we're taking our f of x and we are adding 10 to that value. When I'm looking at terms of x, I'm simply saying that it is 10 units above this value. So when x is 0, my function of f is going to equal -5, whereas my function of g, or g function of x, is going to be at +5. Now, whenever we put f of x in the term, it would be the same as plugging in x plus 5 that'd be the same as adding x plus 5 and then adding 10 to the equation. Oh, I'm sorry. Minus 5. That'd be the same as adding 10 to our x minus 5. That is the entire f of x. And then when we clean this up, that's how we leave it in terms of x. But this one asks specifically to be in terms of f of x. So to recap, we focused on changing only our y-intercept values, what is being added or subtracted to our x variable. With our slope staying the same, going up 1 over 1 for both functions, we are only changing where we cross the y-axis. With minus 4, we moved it down 4. With plus 3, we moved it up 3. Our verbal description of it is saying either it shifts down or shifts up. Another way of describing it verbally is translated. Translated and shift mean the same thing. So in this case it says translated. Over here it says shifted. Those are referring to the same types of movement. And then we use a verbal description to transform or to create our equation.